Okay, so this is our first lesson. This is actually our review unit, so I'm calling it R1.1, so the first lesson in our review unit. Today we're going to focus on adding and subtracting numbers. So hopefully this is a review for you guys. We'll go over it kind of quickly if we can. Make sure when you're setting up your Cornell notes, you put everything in the right place. Make sure to put the date in there, and then put the learning goal underneath. So our learning goal for this is, of course, the students will understand how to add and subtract positive and negative numbers. Alright, so let's begin. Okay, so one of the things that really helps visualizing the addition and subtraction of numbers is working with a number line. And a number line can help you see the relationship between numbers. And we say that each number has an opposite. So we also say that two numbers are opposite if they're exactly the same distance away from 0. So we could have a number here at 4, and we could have a number here at -4, and those two numbers would be opposites. They're exactly both 4 units away from 0, so 4 and -4 are opposites. So just understanding the language, what I mean when I say what's the opposite of a number. Okay, integers. We're going to talk a whole lot more about integers later on in the unit when we look at the real number system and how integers relate to other real numbers. But you need to know that when we talk about integer addition and integer subtraction or integer operations, what that means. So integers are just the whole numbers and their opposites. So here are some examples of integers and non-integers. Integers are 5, 12, -13, 145, -27, and 0. Non-integers are things that might have a decimal, like 2.333, or -5.9. Fractions are not integers, so 1/2 or -2/3 or something like that. Or anything that has a square root that can't be simplified nicely, like for example the negative square root of 5. That would not be an integer as well. So mostly what we're going to focus on in the examples today will be integer addition and integer subtraction. Alright, quickly, let's review absolute value. I know most of us know how to find the absolute value of a number. You just make a positive, right? But it's really important to me that you understand what absolute value really is. And the absolute value of a number is really its distance from 0. So when I talk about the absolute value, I'm erasing, whoops, try to fix that. The absolute value of a number here is its distance from 0. So let's say I was looking at the number 4. How many units away from 0 is 4? It's 1, 2, 3, 4 units away from 0. So of course the absolute value of 4 is 4. Likewise, if I was looking at the number -5, -5 is 1, 2, 3, 4, 5 units away from 0. So the absolute value of -5 is 5. A lot of people just remember this by saying the absolute value always turns a number positive. Some people confuse it by saying it's the opposite of what's inside the absolute value signs, and that's wrong, so don't do that. But I really want you to think about absolute value as distance. That's why it always has to be positive. Distance is always positive. If you ran around a track backwards, you still ran a mile, and that distance is still positive, even if you're going forwards or backwards. Okay? Alright, so now let's really talk about adding and subtracting our numbers. Alright, if I'm going to add integers, or decimals, or fractions, I'm going to look at two different methods to represent this addition. The first method I'm going to look at is a number line, and then the second method is going to be using tiles. I really like the number line method for this. In fact, if you look in the classroom, you'll see a number line right above the smartboard, and I put that there to help you if you ever need it. But it can be a little bit more confusing to use a number line for subtraction. So we're going to use tiles as another way to represent addition. Okay, so here is our first example. Okay, it's a football example, so you'll have to forgive me, but it's a football example. Let's say on a football field, there's 2 plays, and in the first play, the team gains 2 yards, and in the second play, loses 7 yards. We want to figure out what is the result of the 2 plays combined. So the first thing we need to do is turn this into a problem. So if I'm gaining 2, that's like saying positive 2, but then if I'm losing 7, on the next play, I'm adding negative 7. So that's my problem that I have to figure out, right? Alright, so what we're going to do to represent this on a number line, we're going to start at the number 0, okay? And now since we're starting at 0, we have to think, what do I need to do first? The first number is 2, so the first thing I want to do is move 2 units to the right. Okay, and so that puts me right here at 2. Now since I'm subtracting negative 7, the next thing I want to do is move 7 units to the left because that's the negative direction. I'm moving towards negative 7. Or think of 7 as moving in the negative direction on your number line. So we're going to move 7 units to the left from 2. So 1, 2, 3, 4, 5, 6, 7 units. That puts me right here at negative 5. So the result is negative 5. That, of course, means that 2 plus 7 is negative 5. And I know this problem is kind of simple, but I just want to illustrate the idea of moving on a number line. Okay? So the second method I'm going to use to illustrate this example is working with tiles. When I work with tiles, you have to understand what the tiles represent. We'll use tiles a lot in algebra, both to represent numbers and to represent algebraic expressions. So the first thing I want you to know is how do I represent different numbers. So let's say I just wanted to represent the number 3. Okay, so I would use positive tiles to represent the number 3, and I might use negative numbers to negative tiles, to represent negative numbers. So, for example, the number 3 would be represented by 3 positive blocks. You can put them anywhere. Usually we'll end up lining them up, but you can put them anywhere. Okay, is this guy going to show up? I don't know. This guy's being kind of funky. There we go. Okay, so we got our 3 tiles. 1, 2, 3, and that would represent the number 3. Okay. In a similar way, we can use negative tiles to represent negative numbers. So the number negative 2 would just be represented by 2 little negative blocks like this. Now the other part to understanding how to add and subtract numbers using tiles is to understand the idea of 0 pairs. So a 0 pair is when you have 1 positive and 1 negative, right? Because these are opposites, so of course they must add to 0. So these two together would be a 0 pair. And I probably, when we do the math, when we do the arithmetic, I'll probably put like a little rectangle around my 0 pairs like that, so you can really identify the pairs. Okay, got it? All right. So now let's go back to what we were going to do, and that is, let's do the computation 2 plus negative 7. It's the same example as before. We gained 2 yards on the football field, and then we lost 7 yards. Where are we going to be? So this time, we're going to start with 2 positive tiles. Okay, so we'll get out 2 positives, and then put them right next to each other. Alright, so we're going to start with 2 positive tiles and 7 negative tiles. And this time I'll just get them all out there, and then I'll try to line them up. So 1, 2, 3, 4, 5, 6, 7. Alright, so now I got them all there. Let's line them up nicely, because that helps us figure out what our 0 pairs are, and it helps us figure out what we have left over, which is the important part of this. Alright, so line them all up. Put that guy in there. There we go. Okay, so we're adding 2 positive tiles to 7 negative tiles. So the next step that we want to do is make 0 pairs. So like we did before, use a little rectangle or circle or something, and we'll draw a little rectangle over my 0 pairs. So looks like I have 2 0 pairs, right? So I'll take these 0 pairs and see if they'll let me do this. Just think about them as being 0, right? And 0 plus anything is 0. So now, what's left? We have 5 negative tiles left, so that means that my result is negative 5, or 2 plus negative 7 is negative 5. Not so difficult. The problem with using tiles is if you have to add a big numbers together, you'd have a billion tiles out there, and that can get a little bit difficult to work with. So understanding the rules of adding and subtracting positive and negative numbers is really helpful. So here's the addition rules. If two numbers have the same sign, you're going to add them together. You're just going to add their absolute values. And then the sum will have the same sign as the original numbers. So take, for example, 3 plus 5. 3 is positive, 5 is positive. I'm adding them together, so I just add their absolute values. 3 and 5 is 8, and of course 8 is the same sign as both 3 and 5. Now let's look at the second example. It's a little bit similar, but also a little bit different. We have negative 3 plus negative 5. So the first number is negative, the second number is negative, so they have the same sign, and I'm adding them, so I add their absolute values. The absolute value of negative 3 is 3. The absolute value of negative 5 is 5. Add them together. I get 8, but remember, the sum has the same sign as the original numbers, and those original numbers were both negative. So my sum is going to be negative. Okay? So this was my little work below. We know that 3 plus 5 is 9. Now if we want to add two numbers that have different signs, what we want to do is find the difference between their absolute values. That means subtract the numbers. So here's an example. If I have negative 3 plus 5, the absolute value of negative 3 is 3. And of course the absolute value of 5 is 5. So start with the bigger number. The bigger number is 5, and we want to find the difference. That means subtract. So we're going to do 5 minus 3, which is 2. Now the sum of these two numbers is going to have the same sign as the number with the larger absolute value. So in this example, 5 had the larger absolute value, 5 was positive, so the sum would be positive 2. Alright, in the next example we have 3 plus negative 5. Again, the absolute value of 3 is 3, the absolute value of 5 is 5, but this time, when I find their difference, 5 minus 3 is 2, the number that had the bigger absolute value is negative 5. So their sum will be negative 2. Okay, great. So let's move on to subtraction and review our subtraction rules. When I want to subtract on a number line, things can get a little bit tricky thinking, do I go to the right in the positive direction? Do I go in the left in the negative direction? Especially if I'm subtracting negative numbers. So one thing that I always recommend is to turn subtraction problems into addition problems. So for example, here's example 2. Let's say we want to find the difference between 4 and 7, or in other words, 4 minus 7. First I'll turn that into an addition problem. That'd be 4 plus negative 7. So what I'm going to do is I'm going to start at 0, and I'm going to travel 4 units to the right, because 4 is positive. 1, 2, 3, 4. So that puts me here at 4. Now since I'm adding negative 7, I'm going to move 7 units in the negative direction. So from 4, I'm going to move 1, 2, 3, 4, 5, 6, 7 units to the left. And that puts me right here at negative 3. So that means the difference between 4 and 7, or 4 minus 7, is negative 3. Let's look at another example that has us subtracting negative numbers as well. Okay. So let's find the difference between 3 and negative 5. In other words, let's find 3 minus negative 5. So remember, when you have two negatives together, they combine to be a positive. If I'm subtracting, I'm adding the opposite. So this problem actually on a number line is easiest if you turn it into just 3 plus 5. So again, we'll start at 0, move 3 units to the right, 1, 2, 3, that puts us here at 3. And then I'm going to move 5 units to the right, 1, 2, 3, 4, 5, and of course that puts me at 8. So with a number line, working with subtraction can be kind of confusing. I mean, this is really just an addition problem, 3 plus 5. So let's look at how to use number tiles to represent subtraction in a similar way. Alright, so let's use those tiles to find the difference between 4 and 7, or in other words, find 4 minus 7. So first, we're going to start with 4 positive tiles. I'll get my tiles back out again. 1, 2, 3, 4. Now we all know that subtraction means take away, right? But to take away, I have to have something to take away. And I don't have enough tiles to take 7 tiles away yet, do I? So what we're going to do is we're going to add 0 pairs until we have 7 positive tiles so that I can take them away. Alright, so let's do this here. We'll add a positive, okay, and we'll add a negative. So really what we just added is 0. Adding 1 positive and 1 negative is like adding 0. So let's add another one of those. Alright, here's another 0 pair. Dun, dun, dun. Now we can see we have 1, 2, 3, 4, 5, 6 positive tiles. Let's add one more 0 pair. And you can see we have 1, 2, 3, 4, 5, 6, 7 positive tiles. So now the last step will be to subtract, or remove, the 7 positive tiles. So to do that, I might just get, my colored pen here, and remove my 7 positive tiles. I don't know if it'll let me erase it. No, it won't. Yeah. Alright, so what's left after I take those away are my 3 negative tiles. So the result is negative 3. 4 minus 7 equals negative 3. So recap what we did. We started with 4 positive tiles. We added 0 pairs until we had 7 positive tiles. And then we took away those 7 positive tiles to see what was left, which was negative 3. Alright, so let's do another one. Let's find that same difference that we did before, 3 minus negative 5. Again, we'll start with 3 positive tiles. And we go 1, 2, 3. Now this time, I want to remove or take away 5 negative tiles. Well, I certainly don't have any negative tiles there, but I know that adding 0 doesn't change the value of my expression. So again, I'm going to add 0 pairs until I have 5 negative tiles sitting on the board. Okay, so I'll take this, put that over there. Now I have 2 negative tiles. There's another 0 pair. Put that over here. Now I have 3 negative tiles. One more. Boom. Now I have 4 negative tiles. I need one more 0 pair. Doesn't really matter where you put it. I'm going to put it at the front because I'm almost out of room. Okay, so now I had 3 minus negative 5. We added 5 0 pairs, so now we have 5 negative tiles, and we're going to subtract those 5 negative tiles. So let's get our pen out here and we'll go 1, take away 1, 2, 3, 4, 5. We took those tiles away. What remains? 1, 2, 3, 4, 5, 6, 7, 8 positive tiles. So that means 3 minus negative 5 is equal to positive 8. That kind of helps make sense of why sometimes 2 negatives makes a positive and why you can be subtracting and still end up with a number that's bigger than what you started with, like in this case. Oops, not sure what I did there. Alright, so now let's go on and review the subtraction rules. Simple rule to subtract, turn it into addition. If you're not going to use tiles for the problem, make it into an addition problem, and then follow the rules for addition. So for example, if we had 3 minus 5, turn it into addition, and it becomes 3 plus negative 5. If I wanted to use my rules for addition, since now the signs are different, I take the absolute value of the numbers 3 and 5. I find the difference of those numbers, 5 minus 3 is 2, and I take the sign of the number with the bigger absolute value, which was 5, and it keeps that sign. So my answer will be negative 2. Alright, so let's do one last example together. Let's evaluate the expression negative a minus b for these values. A equals negative 3 and b equals negative 5. Alright, so I'm going to start by rewriting the expression. Negative a minus b. Now let's plug in those numbers. That means I'm going to have negative 3 minus negative 5. Alright, so remember, when we have two negatives together, negatives can mean the opposite. So what's the opposite of negative 3? The opposite of negative 3 is 3. Now since I'm subtracting, let's use the rule to add the opposite. So instead of subtracting, I'm going to add the opposite of this number, but the opposite of negative 5 is positive 5. Okay? So add, make a little note here, add the opposite. Alright, and then of course, 3 plus 5 is 8. Alright, and we're all done. Alright, so the next thing that we're going to do here is think about what are some questions that we need to put on the left, and then complete our summary.